The aim of any migration is the modernization or expansion of an existing technical base in a plant without the system crashing and without stopping the plant. At the end of the migration process, the existing system is supported by a far more powerful and more modern system. Simatic PCS7. In this section, you will find out more about this forward-looking process control system, the goal of the Siemens migration strategy. For genuinely comprehensive automation, Siemens developed totally integrated automation for the process automation market. Totally integrated automation is a complete range of products, systems, and solutions for total vertical and horizontal integration in all process industries. Totally integrated automation is applicable to both the processing and manufacturing-oriented industries. Totally integrated automation opens up new potentials for increased productivity by integrating based on a single platform the entire production chain from incoming goods through production to the outgoing product. At the same time, it connects all levels of the enterprise, from the field level to production management level to ERP level. Comprehensive integration with totally integrated automation also means the harnessing of hidden potentials due to continuous observation of the entire production life cycle. Simatic PCS7 is the totally integrated and homogeneous automation solution for all process industries. It is based on standard components of totally integrated automation, such as HMI, software, controllers, etc. Simatic PCS7 covers not only the process control tasks, but also the entire automation of all preliminary, follow-up, and parallel processes at a production site. In addition to the standard Simatic hardware and software components, Simatic PCS7 also uses standardized interfaces for data exchange, based on international standards such as Profibus or HART. At the same time, it also uses new, powerful technologies and internationally established industrial standards, such as IEC, XML, Ethernet, TCP/IP, OPC, ISA S88 or S95, and therefore remains open for future developments. One of the major advantages of Simatic PCS7 is its scalability. It is equally successful in a small laboratory operation or in a large complex with over 100,000 IOs. This guarantees total flexibility when expanding functionality or the scale of the operation. With the simple inclusion of optional packages such as Simatic Batch or Simatic Route Control, the system can grow to keep up with users' demands. To integrate distributed field technology, Siemens uses Profibus, the most successful field bus worldwide. Profibus is straightforward, resilient, and reliable. It supports redundancy and online expansion, and is suitable not only for standard but also hazardous environments. With its all-round scalable redundancy, our process control system increases the availability of every plant at all process control levels. This guarantees trouble-free operation and helps to avoid downtimes. Integrated fail-safe technology is a further step toward a fail-safe automation system. Simatic PCS7 is capable of recognizing process faults and internal errors. With configurable shutdown logic, the plant can be brought to a safe state. Fail-safe automation systems can be configured as a single channel, a fail-safe system with one CPU, or as a redundant system known as an FH system. We offer these safety features to our customers naturally with TÜV certification up to AK6 or SIL 3. The fail-safe configuration is created with the standard PCS7 engineering tool. All Simatic PCS7 hardware and software components are configured with a single engineering system. Thanks to a user-friendly, fully graphical user interface, a technology-oriented configuration can be created without any programming knowledge. The engineering system of Simatic PCS7 has a set of complementary tools for system-wide project-oriented engineering, from configuration of field devices to redundant and non-redundant applications, right up to configuration of fail-safe applications. Simatic batch can be used for process plants with complex batch processes or regularly changing control sequences. This is an option that is completely integrated in the operator control and monitoring strategy and in the engineering of Simatic PCS7. Simatic batch can be configured either as a single workstation system or as a client-server system, and because of its modular architecture and flexible scalability, it can be used in process cells of any size. Together, Simatic Batch and Simatic PCS7 fully cover the process and recipe models described in the ISA S88.01 standard and simplify the process engineering-oriented creation of recipes. To protect capital investment, we have introduced integrated asset management in Simatic PCS7, allowing predictive maintenance, repair, and servicing. We place particular importance on automatic functions for monitoring field devices and other plant components by acquiring measured values that characterize the status of equipment and machines. With Simatic PCS7, the process control system in the enterprise-wide automation system for totally integrated automation, you have Siemens quality from one source. All the system components are developed and maintained internally. Operator control and monitoring systems, flat screens, PCs and input devices, OS servers, archive and batch servers, controllers, network cabling, standard PLCs and text displays, field devices, analysis devices, compact controllers, drives, drive controls, low voltage switchgear, and MIS/MES components. What this means for our customers is comprehensive quality management, tried and tested component compatibility, products with a long life cycle, comprehensive guarantees, fast elimination of bugs, high availability, and long-term availability of supply and preventive maintenance. This, of course, also includes worldwide service and support around the clock. According to international studies, there are several thousand plants worldwide that require thorough modernization, or at least expansion, to keep them competitive in the market. This means that the topic of migration, especially with regard to process control, is becoming increasingly more important to plant operators, since migration generally means the staggered transition to a new technical generation. Accelerated by the waves of innovations in IT and PC technology, the life expectancy of process control systems has changed drastically. While a working life of 16 to 20 years for engineering and operator consoles was considered normal in the 80s, today such life cycles have been reduced to about 5 years. The short innovation times have less effect on closely process-related components such as controllers, I/Os, or field devices. Operator control and monitoring systems, or HMI, on the other hand, are under much greater innovative pressure and are therefore renewed much earlier. To guarantee the functionality of the plant, old and new must be integrated side by side throughout the plant. There are numerous reasons why migration to modern state-of-the-art systems becomes necessary. The risk of failures increases greatly in plants that have been in operation for decades. The vendor of the process control system being used decides to terminate further support for the system. The costs for upgrades, expansions, and for maintenance increase rapidly for old systems. The existing system no longer meets the current requirements. It is simply no longer possible to expand the system as would be necessary to remain competitive. In times of increasing production demands caused by pressure from end users and increased expectations in terms of quality, The inability to expand alone often makes migration the only possible option. The customer can, however, expect even more from a successful migration. Low downtimes in operation thanks to migration. Protection of investment in hardware and software. Long-term reliable operation of plants. High standards of quality of the new components. Simple operator control. And very maintenance-friendly. To be certain to meet the migration objectives and the expectations mentioned, a modern platform and an intelligent strategy are the cornerstones of every migration project. The main aim of a strategy for successor generations is always the same. The existing installed base must be modernized stage by stage without the failure of the system, without plant shutdown and with minimum loss of production. At the same time, where possible, not only the valuable know-how of the operating and maintenance personnel, but also previous investment in hardware and application software must be protected long-term. The aim is clear. The way to achieve it will be decided individually in each case, because Siemens is committed to providing customers with tailored migration strategies to meet individual requirements. The right way for a migration is a stage-by-stage strategy. Plants are not simply gutted. The individual activities are kept separate from each other and therefore allow individual steps to be skipped in some cases. It is also possible to put individual building blocks together in a package. This method has proven ideal for customers, allowing a specific procedure for special requirements and adaptation to the medium and long-term strategy for the plant. Each step automatically generates added value. Convenient products and adapted services support each individual measure. Let's now have a look at 3 typical scenarios on the basis of which we can briefly explain the advantages of migration. 1. Replacing the HMI system. 2. Expansion of an existing system with additional sections. And 3. General modernization. Replacing the Operator Control and Monitoring System, or HMI, normally becomes necessary because spares have become too expensive for the out-of-date system, or the user expects extended functionality by replacing the old system. In this case, we really do only replace the HMI system with the modern operating system from Simatic PCS7. All other components are retained. This means that investment made in controllers, I/O, and application software is secure and provides our customers with the hoped-for advantages, such as the option of MES ERP integration with Simatic IT, or increased productivity of the entire system. When expanding an existing plant, the old system initially remains in place. Only new plant sections are equipped with Simatic PCS7. Old and new continue side by side in mixed operation, with a common operator interface. Controller communication is implemented using a gateway. This gradual modernization, starting with the new plant section, provides not only greater transparency for the operator, but also functional expansions such as field bus technology, IT integration, and totally integrated automation, etc. As requirements grow, the system can be further expanded with Simatic PCS7. The discontinuation of a process control system by the vendor, in other words, discontinuation of further development and support, is the main reason for a comprehensive plant modernization. The need for functional expansion, or the desire to avoid plant downtimes, can also be the motive for modernization. Whatever the reason, the old control system is replaced by the modern, forward-looking Simatic PCS7 process control system. In some cases, without interrupting plant operation, the existing field devices are connected over termination adapters. This protects prior investment such as field wiring or hardware components, as well as the valuable application engineering. Following modernization, all the advantages of Simatic PCS7 as part of totally integrated automation are available, such as simple and safe process control, convenient operator control and visualization, powerful, fast, and fully integrated engineering, openness at all levels of the system, flexibility and scalability, redundancy at all levels, fail-safe automation solutions, flexible solutions for batch processes, and much more. We support these three typical migration situations in each individual step with the products we have developed. 1. Replacement of the old system with the Simatic PCS7 operating system that controls the plant moving forward. 2. Creation of the engineering libraries for PCS7 AS and OS, FP. Here, the valuable configuration information from the old system is adopted. 3. Introduction of network gateways, developed for trouble-free exchange of information. 4. Creation of interfaces to PCS7 for I/O modules of other vendors. 5. Use of field termination adapters for PCS7 that ensure that the existing field wiring is retained. Each step is supported by specific services. Within the concept of our individual migration strategies, the migration products rank equally alongside standard products. For our customers, this means worldwide guarantees of sales support, regular preventive maintenance, hotline support, reliable support for all system components, long-term reliable operation of plants, and secure investment in migration. At the same time, the maintenance of existing older systems is also part of the Siemens strategy. It goes without saying for Siemens that migration of our own control systems to Simatic PCS7 is an essential cornerstone of our continued business relationship with our customers. Since 1996, we have been providing migration solutions for the smooth transition from Teleperm M to Simatic PCS7 and have modernized thousands of plants. In the meantime, we have also successfully implemented migration procedures from Apax Plus and Simatic 505 to Simatic PCS7. In recent years, Siemens have proven their expertise in numerous successful migration projects. Our specialists worldwide have years of experience in engineering, commissioning, and service. They can inform you about the migration options, analyze the plant, advise you individually, and then provide you with a detailed proposal. Today, we can also offer migration solutions for control systems from other vendors, such as Bailey. Migration solutions for other vendors such as Emerson, Honeywell, Invensys, and ABB are either being planned or on the way. The openness of Simatic PCS7 at all levels, for example for data exchange, and the support of international interface standards provide completely new migration options for customers who have not yet worked with Siemens systems. One extremely important building block in each migration project is collaboration with expert partners. When migrating from systems of other vendors, close cooperation with the customer's system integrator is a matter of course for Siemens. The system integrator has years of know-how and knows the customer requirements down to the last detail. The plant operator can then be sure that efficient collaboration between the system integrator and Siemens will result in the optimum migration solution. With the modern, forward-looking process control system Simatic PCS7, individual migration solutions, migration products and services, years of know-how in process control and migration, and with worldwide service, Siemens can demonstrate considerable expertise in this area, earning the confidence of customers as a reliable partner. Now that you have seen our migration strategy in addition to the optimum target system, we will now take a look at the technology Siemens has developed for migration. Siemens has been active in process automation for decades. Our know-how in this area has grown year by year and with every new customer requirement. From the first migrations of Teleperm M to Simatic PCS7 right up to today, we have continued to gain more experience and converted this experience to even more efficient technology. In principle, the structure of every process control system is the same. They all have object types, object instances, address information, control software, graphic user interfaces, etc. During a migration, the target system must understand this information. We have created an internal development platform for this process, Database Automation, or simply DBA. With the aid of a plug-in interface, the configuration data can be read in from any process control system and displayed and configured using a standardized user interface. This technique creates a universally valid migration infrastructure that permits simple docking to different process control systems, thanks to the module architecture. DBA allows migration of OS, batch, and controller data, and creates a consistent look and feel for every control system migration. DBA is, of course, fully integrated in the engineering system of Simatic PCS7, allowing genuinely uncomplicated and homogeneous migration to the PCS7 target system. This has been proven in many migrations from our own as well as from various systems from other vendors. DBA transfers the process data of the old system to PCS7. This includes the plant view or plant hierarchy, process tag types and process tag instances, standard faceplates, batch data, recipes, etc. Siemens also provides a graphics conversion service with which existing graphics of certain old systems can be converted for use in PCS7 at a fraction of the cost of a new configuration. The migration technology described here is incorporated in the migration products that are now available on the market as standard products for a variety of old systems. Care was taken to ensure that these products fully support the typical use cases with which you are familiar. To complete this section, let's have a brief look at the user interface of DBA. In the next section, the practical part of our presentation, you will see its strengths in greater detail. The hierarchical plant view, complying with ISA S88, is used to group and display a project according to technological aspects. Process objects are presented clearly according to the plant hierarchy. The process object view displays all aspects of the individual process objects in the form of a table. Here, names, types, and addresses on the controller are displayed, and their relationships indicated. This section provides 3 typical conversion examples. The procedure will use an Apax Plus conversion as the example, but the procedure for other systems like Infi90 from Bailey is the same. In the first use case, the existing Apax Plus system operator station is to be replaced with a new PCS7 operator station in a client-server architecture. The PCS7 Apax Plus OS server is connected with the system bus, the M-bus, and therefore has access to the subsidiary Apax Plus controllers. Via the OS Ethernet network, the PCS7 OS clients are connected to the engineering system. All the engineering is done on the engineering system, and from here the application software is downloaded to the server and the client. In the second use case, we would like to show how the existing plant can be extended by a new measuring point, using the remaining legacy engineering console formation. This change will be detected in the engineering system, and the changes are downloaded into the PCS7 Apax Plus OS server and the PCS7 OS client, online. In the third use case, the existing plant will be extended by a sub-plant based on Simatic PCS7. In addition to the present server, an additional PCS7 OS server will be added and connected to the OS network as well. Based on that connection, the operator, sitting on the PCS7 OS client, has a common and consistent monitoring and operating for both parts of the plant. Welcome to the practical part of the multimedia presentation, Migration Strategy of Simatic PCS7. Here, we would like to present 3 different migration use cases. The first migration use case shows how an existing HMI is replaced by a modern PCS7 operator station. You will see how the migration products work and how easy they are to work with. You will also see how the migration products not only save a tremendous amount of time and effort, but also how they exclude accidental errors right from the beginning. In the second use case, a process tag is added to an existing plant. This is inserted online in the operator station during operation without affecting process control. In the third and last use case, a plant is expanded by a new section using PCS7. The operator should be able to control and monitor the new section of plant alongside the previous or legacy system. We will present these use cases using the example of migrating Siemens's DCS Apex Plus to PCS7. The procedure for other DCS systems is similar. Please select the use case that interests you the most, or simply watch all 3 use cases. In this use case, an existing database with the engineering data of an Apex Plus controller will be read in by DBA, and the picture hierarchy will be set up for the OS in DBA. An OS project will then be created, and this will be specified as the target project for all pictures. In the last step, the OS is compiled, and the tags, messages, and picture hierarchy are automatically created with all the necessary pictures. The block icons of the process objects are also created, and they are assigned to the faceplates. The first step is to open a new project in DBA and to browse for the engineering data of the 2 controllers to be controlled and monitored from the operator station. The databases iPlant and Tower1 have the status changed because the objects that have been read in have not yet been used on the OS. The Update Controller Objects function reads all objects contained in the 2 controllers. And displays them in the table with their names, types, and addresses on the controller. The assignment column is empty, since no process object has yet been assigned to an OS. By selecting a controller, the corresponding process objects are displayed. With the Auto Assign function, all the process objects of Tower1 are assigned to a Templates folder in the plant hierarchy. The Templates folder has a subfolder called Tower1, and this, in turn, has 2 further subfolders with the names Inc1 and Inc2. Inc1 and Inc2 are hierarchy levels that already existed in Formation, the engineering tool of Apex Plus. Here, we can see one of the advantages of DBA that always pays dividends when the original engineering data has a hierarchical structure. DBA then evaluates this and automatically sets up the picture hierarchy accordingly. As always, you have the option to set up the picture hierarchy manually, based on your own criteria. The procedure for iPlant is analogous. For the picture hierarchy on the OS, the two folders are now moved to the first level. The objects remaining in the Templates and Templates 1 folders are not required on the OS, and both folders are therefore deleted. The name Boiler 1 is now changed to Boiler, and Tower 1 to Tower. To obtain an overview of the status of the iPlant controller, the resource status is stored in a separate picture. In the overview of the OS, System will be the first entry, followed by Boiler and Tower. System is therefore located at the top of the plant view hierarchy by DBA. The OS can only be compiled if the OS project has been created and assigned in DBA. The OS project is created in the WinCC Control Center. The project editor then needs to be run, so that various basic settings such as the resolution of the monitor can be made, and to copy required files to the project. A screen resolution of 1024 by 736 is used here instead of the recommended 1280 by 1024 or 1024 by 768 screen resolution, in order to achieve the optimum picture quality in the video. The project does not yet contain any tags or other project-specific data. After the OS project is created, it is assigned to DBA. In this dialog, we select the server application type and assign it to the OS. The picture hierarchy objects must now be assigned to the OS. This is necessary because a DBA project can include several operator stations. The DBA project is saved in the path of the OS. And the OS is compiled. The first time the project is compiled, it is compiled completely. The tags, messages, block icons, and the picture tree are created. This completes all the work in DBA. The tags were inserted in the OS project. The block icons were created in the pictures, such as in the boiler picture. And Ink 1 picture. The next step is to create the server package. Here, the name of the server is entered. Finally, enable the Online Changes option. Once the user settings have been made in the background, the project is closed. The server is then downloaded. Next, the client project is created, and the server package of the server is loaded and downloaded to the client. The client package is therefore created first. The project editor is started. The screen resolution is set to 1024 by 736 again, and closed. The server package is now loaded. The server package has been loaded. Once again, the user settings are made in the background. The project is now closed. In the last step, the project is downloaded to the client. The server has been started in the background. The client project has been opened on the client PC. The project is now activated. The overview on the client shows the structure defined in DBA. In Tower, one picture level was created with the pictures Inc. 1 and Inc. 2. The block icons of the objects assigned to the pictures in DBA were created in both pictures. The block icons were also connected to the appropriate faceplates. Working with the faceplates is exactly the same as in standard PCS7. However, as in all the migration products, the block icons and faceplates have been adapted so that the operator recognizes the previously familiar user interface in the new HMI system. This reduces the potential for operating errors. The block icons have also been generated in Boiler. The pictures shown were generated in the background using the existing block icons on the engineering station. The new pictures were based on pictures migrated from the previous Apex Plus HMI system. When selected, the pictures are displayed with the modifications. This completes the first use case. You have seen how simple it is to configure Simatic PCS7 OS with DBA from the engineering data of Formation. the engineering tool of the Apex Plus and Quadlog process control system. The automatic sequences drastically reduce possible migration errors. As you have seen, the picture hierarchy, all tags and messages, the block icons, and their faceplates are automatically generated. It is clear from this example that using DBA and the migration products can save you time and engineering effort when migrating from your old HMI to PCS7 OS. You now know how DBA works based on the example of Apex Plus. The steps to migrate the HMI components of other process control systems are similar. In the second use case, we assume that a new motor has been installed in the system and that the engineering was completed successfully with formation. The data on the Apex Plus controller was, of course, modified at the same time. DBA is now used to update the PCS7 Apex Plus OS server with the new configuration information. After starting DBA, the status of Tower 1 is set to the Change status after 10 seconds. This is the default DBA database update frequency. The cycle within which the existing databases are checked for changes can be set here. After updating the controller objects, the motor PMP200 is displayed in the table. This motor is assigned to the picture called Inc2. The OS is now compiled to implement the changes. Since the configuration changes do not affect the picture hierarchy, the option to generate the picture hierarchy is disabled. The block icon of the new motor with the name PMP200 has now been inserted in the Inc2 picture, and its tags generated. The block icon of the motor is placed at the top left. It is now moved to the correct position. The picture is saved. The changes must now be downloaded to the server. The download is made while the server is running. The changes become visible the next time the operator opens the Inc2 picture. The client is updated automatically by the system, and this does not need to be restarted by the operator. The operator working on the client was not affected by the change. The next time the Inc2 picture is selected, the operator will see the block icon as it was created in DBA and moved in the graphics designer. As you have seen in this use case, changes made on the controller are automatically detected simply by DBA and included in an operating OS without stopping the process and without affecting the previous migration. When using the migration products of Simatic PCS7, you can optimize and maintain your previous system with the familiar engineering tools and include these changes in your HMI system without stopping the process and with minimum effort, even when no redundant OS servers are used. In this third use case, a new plant area is added to a plant that is currently automated with Apex Plus controllers and PCS7 OS HMIs. You will see how this migrated automation system can be expanded with Simatic PCS7 components to automate the new plant area. While the operator could previously only control the plant section automated with Apex Plus, the aim now is to give the operator on the OS client access to the new plant section. The project of the new plant section is stored on the engineering station that we used earlier for engineering the Apex Plus PCS7 OS. A new Simatic PCS7 project is created to control the new plant area. Simatic Manager is used to configure this plant area. Using Simatic Manager, a new Simatic PC station is created and named Apex. A PCS7 OS application is added. The Ethernet adapter is inserted according to the setting in the Apex server at index 10. The ISO protocol is enabled and the MAC address of the server entered. The configuration is compiled and downloaded to the Apex server. The OS is given the name AP Plant. This corresponds to the name of the Apex Plus project. Simatic Manager is closed, and the Apex Plus project to be included is copied to the Simatic Manager project folder. Simatic Manager is reopened. The project path was entered earlier in the display properties of the Apex OS. The package was generated and the project downloaded to the server. In this use case, the intention is to be able to control and monitor both the existing and new plant sections using the same PCS7 OS clients. At this point, load the Apex server package on the client. The changes on the client can now be centrally downloaded using the PCS7 Make dialog. This completes the ES engineering. The client is activated. The overview of the Apex server is displayed. The pictures of this server can be selected just as previously. The server with the section automated with Simatic PCS7 can be selected here. The overview of this server is displayed. The pictures can be selected as normal. The motor called J191B can, for example, be operated as normal using the appropriate faceplate. Stopping the motor leads to overflow in tank B190 and triggers a warning and an alarm. The warning and the alarm are entered in the alarm list. In the Apex controller, an alarm was triggered by FIC 204 and LIC 205. These alarms are now also shown in the alarm list. One particular advantage for the operator is that the alarms are displayed by both plant sections together and in the correct chronological order. This completes the third use case. You have now seen how simple it is to expand or modernize an existing plant. In the video examples, an Apex Plus system was updated to use the modern PCS7 OS HMI. Changes were made to the updated system without shutting down the original process. And in the event of a process expansion using PCS7 components, the existing and new process areas can seamlessly share the same PCS7 OS clients. Apex Plus is, however, only one of many possibilities that could illustrate the migration potential and integration potential of Simatic PCS7. Please contact your Siemens representative to learn more about Siemens migration products. Thank you for your interest.